Hello, everyone. Welcome to ENPM818O, Networks and Protocols for Cloud Engineering. I'm pretty sure that everyone who is watching this video has accessed the cloud intentionally or unintentionally. In fact, when you turn on your 5G phone, the first thing that your phone does is register with the network. That network is called as a 5G core network. These 5G core network elements are typically implemented on the cloud. Of course, you have also heard of Amazon Cloud, Microsoft Cloud, iCloud, etc. In this class, you learn everything about what happens in your device when it accesses the cloud. That device could be in the form of a laptop, or it could be your phone. And that is shown in this chart as client on the left-hand side of the chart. You will also learn everything about what happens on the cloud side, namely on the server on the cloud side. And that is shown on the right-hand side of the chart. And of course, you'll learn everything that happens in between the client and the server, which is shown in this big blob, which essentially is the IP network that is there between the client and the cloud server. So we'll learn everything about what happens inside the IP network between the client and the server. In order to fully understand end-to-end communication between the client and the server, you need to be able to grasp the concept of a layered architecture. And that is the basis with which networks work, is in terms of the various layers. On the right-hand side on the client, on the left-hand side on the client, you'll find that there are 5 layers. And on the right-hand side on the server, you'll find that there are 5 layers as well. That is called as a TCP/IP model. In this class, we will go through each one of these layers and explore in depth as to what the functions of these layers are and how to actually design these layers. We start off from the bottommost layer, which is the physical layer, and we'll see what functions this physical layer does, namely the waveform design. We'll talk about Shannon channel capacity. We'll talk about error correction and detection schemes at the physical layer. Then we move on to the layer above it, which is layer 2, which is also called as a data link layer. And we're going to learn about the retransmission protocols in the data link layer. As you can see, the data link layer is talking to a data link layer in the network. And that requires a reliable transmission. For example, if you were on your phone and you were communicating with the cloud that's somewhere out there, your phone will be first talking to the tower. And so this layer 2 data link layer is a tower. And we need reliable communication between the phone and the tower in order for you to have a reliable communication to anywhere on the internet. And that's where the retransmission protocols come into play. So we're going to learn about 3 retransmission protocols that are evolving from one to the other. Then we will also learn about what is known as a MAC layer design in data link layer. And this is applicable for both wireline and wireless networks. And we'll talk about the various MAC designs and what the efficiencies are of the various MAC layer designs. Then we move up one more layer, and this is probably the most important but the complex layer, which is the IP layer. And as you can see, the IP layer is the binding layer across all the elements, starting all the way from the client to the server and back. It is the common layer. In the IP layer, we're going to learn about routing protocols, IP addressing schemes, IP version 4, IP version 6, differentiated quality of service. That is, you may be invoking different types of applications, voice, video, web browsing, file transfer, and they all need different treatments And so we'll learn about differentiated quality of service. We'll also learn about queuing theory, because when you design a cloud, packets that come from the clients to the cloud, they need to get processed, but before they get processed, they get queued. And in order for you to deliver a very fast processing cloud, you need to minimize the queue depth. And so here we're going to learn about the queuing theory and how to minimize the queue depth, how to select your processors, how much memory you should have in your routers or in your cloud, so on and so forth. And that's all part of the IP layer. And a very important topic that you'll learn in this class is what's known as software-defined networking. This is a departure from the traditional networking, where there is a separation of the user plane and control plane, so that you remove the burden from the individual IP routers to actually execute the routing algorithm. It's done by a central server. And so you're going to learn about this new concept called software-defined networking in this class. Then we move one more layer above it, and that is the TCP layer and the UDP layer. It's also called as a transport layer. Here you're going to learn about error control, congestion control, and flow control. These are needed in order for you to have a very reliable transfer of data. And after we have completely understood the transport layer, we move a layer up, which is the application layer. And here, at least in this class, the emphasis will be on Internet of Things applications. There are many IoT application protocols that you'll learn. This is very important in this day and age because Internet of Things is catching up. And so you'll learn about the different application IoT protocols that are in place today, and then you'll be able to appreciate the differences between those IoT protocols. And in a nutshell, in this class, what this class allows you to do is it builds the foundation for you to understand the design of wireline and wireless IP networks and the associated protocols. Once you complete the course, you'll be able to learn the what, how, and why aspects of data network design and cloud access. That will further enable you to understand and appreciate the most recent advances in data networking design, including 5G. You'll be able to evaluate the performance of routers and cloud entities in terms of delay, throughput, packet drop rates, etc. You should also be able to design cloud platforms that achieve the design performance targets. You should be able to conduct trade-off analyses of the choice of different IoT protocols that I was mentioning in the earlier slide. And last but not least, there are various standards defining all of these protocols. They are standardized in IETF, ETSI, ITU, etc. So you should be able to pick up any of these standards and read these standards and relate it to what was taught during this course. So I hope you'll enjoy this course, and thank you very much.